This is a short series of slides to assist paraglider and hang glider pilots in using Skew T meteorological graphs. In the remainder of this series, we will look at 5 aspects of the Skew T graphics: where we can find them, what do they tell us, what all the lines on the graph are for, and how to read them to get some useful information. Finally, there are a few examples that may help pilots test themselves and learn. Let's start by looking at where we can get our Skew T graphs in 2025. There are a couple of places where Skew T graphics are provided as part of a paid subscription service. One is Meteo Blue. This is the service that is used by Kelly Farina, the author of Mastering Paragliding, and who now runs a guiding and coaching service in Bassano del Grappa in Italy. He uses Skew T graphs as part of his daily task planning and briefing, and frequently posts his comments, including annotated Skew T graphs, to his Facebook page. This is the Meteo Blue output, and an example of Kelly Farina's annotations. We will look at a few more of his notes later on in this series. Another subscription service is the increasingly popular SkySight Met tool. I've no personal experience with this service and haven't seen their Skew T toolset. A popular and free meteorological tool that is available both as a web page and as an app for your mobile telephone is windy.com. This tool offers the Skew T graphic when you right-click on any location. This is the basic Skew T graphic included for free with windy.com and also available via the app. There is also a free-to-use additional plugin called FlyXC available on the desktop site. Called Better Soundings, this plugin is hard to access via the phone app, but does offer a slightly different presentation of the same windy data that can be a little bit more user-friendly. We can compare the standard windy sounding and Skew T, illustrated in this image, to the FlyXC soundings version as illustrated here. There are several nice benefits to this presentation of the same information, including the option in the top left-hand corner to focus down on the lower part of the sky in which we fly, in this case up to about 6,000 meters. It also rather neatly shows the height of expected cumulus cloud base and drops a green line down to illustrate the convective temperature. That's something we'll expand upon later on in this series. Showing the y-axis as height in meters is quite nice rather than using atmospheric pressure. One really helpful feature available when using Windy is the facility to float your cursor over the soundings lines and read off key information. It is also helpful that the standard Skew T graphic states the convection temperature, the convective condensation level, and the lifting condensation level. We will learn more about these parameters in a later section. Finally, for now, the most well-used service amongst the free flight community is probably RASP. This is also free to use, but digging out helpful soundings information and Skew T graphics is slightly more tricky than a simple right click. One little aside at this point. This image in the screen shows the sites in the UK where the actual radiosonde meteorological data is collected. When we generate Skew T graphics for other locations of interest and for any dates and times in the future, then those graphics are all projected models based on that real-life readings that we take place elsewhere. We will discuss more about data collection later in this series. If you go to the home page for RASP, the main menu now offers users the chance to generate their own custom soundings for a chosen location. For the custom soundings, you you can choose any of the many gliding association turn points that are listed in the drop-down menu. The map of BGA turn points is available on the main menu, and you can float your mouse over the map to identify the name of the turn point that is closest to your intended flying site. Having chosen the turn point you're interested in, you can then select the day and time for up to a week ahead and hit Get Turn Point Result. This is what the standard RASP soundings graphic looks like. RASP refers to our Skew T graphic as a sounding. This is quite a nice clean graphic image and shows both heights and pressures on the y-axis. As we will see in a later part of this series, it also shows cloud and rain along which side wind speed and direction. Finally, projections for dew point temperature and atmospheric temperature are very clear. It is only the facility to look at convective temperature and convection condensation which is not terribly easy to interact with. Using the RASP graphic, this is an example of a winter's day in the UK with westerly winds and lots of low cloud and rain. The rain is in the green line to the left and the cloud is shown as black. This is an example of the RASP soundings output for a thermic day in the UK. In the most simple terms of all, this is a day that would catch the eye of a free flyer because the red and blue lines form an hourglass or egg timer shape. They are wide apart close to the surface, travel closer towards each other as we rise from the surface, and then travel apart from each other again. In the next presentation in this series, we will explain what these lines are doing and what this means in more detail. We will look at what we can learn from using Skew T or soundings graphics as part of our flight planning and what the various faint background lines on the Skew T graphic are